Welcome, everyone. Today we have a webinar hosted by p4.org. My name is Andy Fingerhut. I am a member of the P4 Technical Steering Team. Today we have, I'll introduce our speaker in just a moment. First, I wanted to remind you, everyone, that this webinar is being recorded and it will be made available, publicly available afterwards. Follow the P4 mailing lists or the p4.org website for links to the recordings. I would like to ask everyone to hold their questions. You could submit questions at any time or comments using the chat button at the bottom of your screen. I'll be curating questions at the end to ask Reza. And so let's see, let me introduce Reza Falahi is our speaker today. He has a master's in computer networking from Bu Ali Sina University in Iran. So I will turn it over to you, Reza. Please go ahead.
Of course, hello everyone. I am very glad to be here with you today in one of the P4 Developer Day presentations. And of course, as Andy told, my name is Reza, and since our time is limited here, I'll try to be as brief as I can, or to actually cover all the topics that we want to talk about. But before we jump into the first section of our talk, I'm going to have a brief overview of the topics that we're going to be covering here. The main goal of this talk is actually to say that how P4 is able to help us overcome the security concerns, specifically the SDNs aligned with the AI solutions. So it's not going to be getting deep into the details. I'm just going to be covering the whole idea, specifically the experience that I personally have. And with that in mind, we're going to be having a first section dedicated to the SDN in order to actually reach the point to state the problem and the limitations that we have, by the way, again, in the security concerns and security fields. For the SDN. And then we're going to be covering how and P4 is going to be helping us in this regard. Of course, to the community, this is not anything unknown. But to have a comprehensive review of this, I'm going to have a dedicated section for this. Of course, the second section of our talk will be about the AI solutions and how they are going to be helpful for us in case of the network attacks and security mechanisms. And in the end, we're going to be covering, wrapping all the things and seeing how the things are going to be useful for us. So let's jump into the first section of our talk, which is the SDN. This software-defined networking, of course, has brought us more flexibility and more modularity and more control, more unified control over the networking, contrast to the traditional network architecture. Of course, you know this. And this is great. It's the promising network architecture of the future. But the problem here is that the separation of the control plane from the data plane actually replaced the vendor-specific devices with the general-purpose devices, as you already know. And these general-purpose devices lack the functionality and lack the actual processing that we need for most of the actually security fields for proposing the solutions and things like this. Therefore, most of the community members are trying to actually being dependent on the controller side, okay? And the problem is exactly here. Since the controller resources are limited, and by the way, we're talking about larger scale networks and things like this, so we're going to be the worst case scenario possible. And yeah, the controller resources are actually the resource management of the controller is a great concern to have, and this will cause us the problem. Specifically, since we're talking about the security mechanism, in case of the network attacks, this will bring so many problems. And for example, we have three sections of components, three layers of the components in the SDN. It's controller, data plane, and the communication, North-Span API communication links between them. And this can bring even more problems, even more security concerns when in case of the attacks. So suppose we're talking about DDoS attacks, for example. By the way, why did I choose the DDoS attacks? It's because uh, they don't need that kind of a hard that kind of a resource, hard resources. They can be simply launched with a simple script, and they are getting smarter and smarter, and they will eventually uh, end up with destructive results. Okay, so suppose these type of attacks focusing on different section of the SDN, for example, data planes. They can flood the data plane of the forwarding tables, for example, of the general purpose devices, or even it can lead to the communication links flood, or even taking it further indirectly trying to manipulate the controller or do some kind of things inside the controller. And I'm not going to say that this will result in a single point of failure inside the network, but it can be, since we have a cluster of the controllers, it can be causing serious problems from a, let's say, big portion of the network. So uh, this is the main problem here. And what were the solutions in this regard is that we can divide it to two sections. Okay, we have some practical solutions which we have already here, even with the traditional architecture that we're using right now, and we have the solution types that the community members, specifically through the articles, research papers, and things like this, are proposing. So. Uh, we can divide it to the controller dependent solutions or the third-party tools like apps, software, hardware, things like this. So in controller dependent solutions, the thing is, uh, the resource of the controller will be used in order to actually extract information through the network or do some heavy tasks or it will be some kind of processing burden overhead to the controller. And this is not the thing that we actually want to have inside the network, specifically inside large scale networks. And in some cases, it might become an attack surface itself. So this is one problem. And the second one is actually the intrusion detection systems through the intrusion detection systems and same systems. And of course, you knew that these are, again, vendor specific. So it's something like going back toward the traditional architecture somehow. And of course, you're giving out some kind of informations from your
Hmm.
network to these type of devices. Of course, I'm not going to say that these are not going to be useful or they're
What
not
did I say?
I was telling that the other solution is that by giving out the information, like port forwarding or cloning packets through these systems, and these systems are great and they are getting really evolved, specifically with AI solutions. But the thing is that with the help of P4, we can have all. Not, I'm not gonna say we're gonna be comparative component opponent to them, but we're gonna have what I'm trying to say is that we have the programmability through the P4 and we can implement the functionalities, the features that we need inside the data plane itself without giving out the information, without actually being dependent on the controller. Okay. The whole point of actually bringing this was this, that we have that kind of, when we have the programmability, we have the ability to actually create or customize the features that we need. Okay, and this is really important in case of the security mechanism and security fields, because information, as you already know it better, are so important in some cases. So this was the actual main problem here. And in this second section, I will try to actually bring out some functionalities of the P4 code that will help us to actually create some kind of mechanism to actually let's say mimic or simulate or actually customize the functionalities that an intrusion detection system and a same system can actually work for us. without being dependent on the controller plane. Okay, so in this slide, as you've noticed, I've categorized the type of task that will be used by these type of systems. For example, traffic collection, feature extraction, detection of the anomalies, signature of attacks, these type of things. Okay, and in this section here, I'm trying to actually bring out the features. Of course, I'm not trying to create a tutorial here to how to do it. I've done it in my previous researchers, but I'm trying to actually bring out the sections of the code that will help us to actually create those kind of features. Of course, these functionalities here are not anything new to the P4 community, but in case there are some new community members that might find these things useful, I decided to bring these things up. So we're going to be describing things based off actually traffic analyzation and the packet inspections. And the first things first are the uh, uh, packet header definitions. Uh, Suppose in security fields, we want to create some kind of dedicated protocol header in case of transferring information between the devices, the nodes in this system, in the network. These feature, of course, it's obvious, but it's very important. It's very crucial to have these kind of functionalities. This will enable us to actually adapt ourselves to the new security mechanisms without being dependent on vendors to actually waiting for an update for things like this, or you can actually create whatever idea you have using these type of things. You can even encapsulate the TCP/IP protocol inside another type of headers that you create for your own concerns and your own mechanisms. Okay, uh, this is a great functionality here that we can have access to the protocol stacks and protocol header values. We can define it as per our need. Okay, the second section of it is, of course, I try to bring out the simple section of the code here as well for just for demonstration purpose. The second section for the features that will help us are counters and meters, for example. These are useful, of course, as far as I know, for the BMV2 switches, I wasn't able to actually read them directly through the codes. But even through the switch command line or the controller API, these are really great features when you want to gather information from the traffic. For example, number of the packets per second, things like this. You can even rate limit the output of the switches in order to do some management things and things like this. Okay. The other one are the queue buffers, for example. I've used this feature in one of my in my latest work, of course, which has not been published yet. And these are really great features. They're simple, but if you think creative enough, you can you greatly use them. Okay, suppose you have dense networks, you want to do quality of service things, and these are going to be very useful. You can even rate limit the output of the switch with these. You can see how occupied the switch is, congestion control, things like this. This is going to be very useful. And the other ones are registers and hash functions. Uh, uh, if, from my opinion, the registers and hash functionalities are the most important features of the P4 language code. Okay, without registers, we wouldn't be able to use stateful data processing. And if we don't have the stateful data processing, the solutions are not going to be that kind of practical thing. Okay, they're just going to be on paper. But this one here, the registers, are going to be helping us to actually store and restore the information from the traffic, from the packets that we need to actually feed them towards the dedicated modules that we need for security concerns. For example, in the same systems that we're trying to analyze some kind of things, some kind of network related information, they get the port forwarding things like dedicating a packet towards that specific port. But here we can use registers to actually do all the things inside the switch itself. We can gather information, save them, retrieve them, modify them, and do all the things here. And the other one is hash functions. Okay, these are really simple features, but I found them personally very useful. Without these hash functionalities, we're going to be great functionalities. Of course, I'm sure you will find it useful as well. And they will help us actually create those kind of unique values that we need. The other feature, of course, is that we are able to create our custom control blocks. Okay, suppose we can have our custom control blocks for a security mechanism, dedicated security mechanism towards like a pipeline. And we can have another one for quality of service, another one for management, and we can even utilize them in a way that we want. Okay. So the next feature is the packet regeneration mechanism. Okay, this one is extremely useful in case that we are trying to alert, for example, like a intrusion detection system and things like this. This will help us actually regenerate the packets in different manners. For example, we can clone it, recirculate, resubmit, replicate the packets through different sections port. And yeah, this is a great feature that we can use for alerting or actually traversing the information through our different nodes of the network itself. So up to this point, I was trying to actually bring out some portion of the P4's language functionalities that will help us to get information through the traffic itself. But from here, I was try to actually get some information about the packet inspections. You see, again, we do have a definition of the headers, but actually to the values of the packet itself. This is obvious. Of course, this is the main reason that P4 is actually doing some tasks, but we can use this for security manners to actually do some deep packets inspections. You see, there are some kind of attacks that are getting smarter and smarter. Specifically, for example, slow rate DDoS attacks. These type of attacks actually, as you know, DDoS attacks try to occupy these servers, or they target resources through volumetrics. Let's say, for example, packets, requests, things like this. They say a large amount of data towards their victims. But we do have slow rate attacks as well. Okay, these slow rate attacks try to manipulate some specific values inside the packets itself. So with these features having available in P4, we are able to actually inspect the values of the P4, the packet, to actually reach that packet inspection levels. And of course, through the whole level of defining the packet processing procedure, we do have all the functionalities like parsing. We can extract some information. For example, I myself was able to actually get specific values of the HTTP header, of course, that lies in the payload of the TCP/IP packet, and through the parsing, okay, in the parser of the pipeline. And of course, we do have some default standard metadata that will gather some information about the packet itself. We can create some custom metadata based on those information. Then we have the headers, custom data planes, custom data types, and tables, of course. And these are the whole things that will actually help us to gather information based on the traffic flow and the packet values itself. So the whole objective here, the whole thing that I'm trying to say is that we can actually use the P4's functionality, the P4's language, to extract the necessary information, specifically in attack detection and attack anomalies detection, using the P4 switches, P4 functionalities, P4 language itself. And it's not going to be necessarily some kind of fancy stuff, kind of intrusion detection system that you actually need for yourself. So we can actually gather those information and actually alerting the controller here to about, for example, an attack is taking place, and what should we do? Since the controller is the intelligence and the thing here is that we're not giving out any kind of information to a third-party app, any kind of third-party device, anything. And the controller, okay, is just the receiver of the information. It can use it, it can bypass it to another module and things like this. We save the resources of the controller here. And the P4's programmability is doing the old tasks. So having this in mind, and we cannot solely depend on the P4's functionality and P4 language. Nowadays that we have AI solutions and dynamic solutions being replaced by the static solutions, there is a missing point in most of the security actually ideas that are being proposed. Okay, and that is the intersection of our talk with the AI solutions. But before we actually bring up the ideas of AI nowadays, I will try to actually explain why do we need AI solutions at the first place. Suppose we're talking about a type of attack, okay? Attack type 1. These attacks are dynamically are actually evolving through time, and they actually uh, uh, somehow they try to bypass the mechanism that we actually propose. So suppose that we are proposing a static solution that works based on how an attack is being taken place. For example, we have a slow loris attacks that try to manipulate specific values of the HTTP payload. Okay, the example that I just previously talked about. So we propose in a static solution. We say, okay, find those kind of payloads. If you see the patterns, block the packets. What's going to happen if the attack actually evolves? Okay, this is obvious. We're going to go to the second solution, and it repeats itself. Okay, so we need some kind of solutions that works based on the actual behavior, the network behavior of the attack. I'm talking about the attack, but we can actually wrap it up in all kind of tasks. For example, quality of service management, all kind of tasks. But specifically in attack detection sections, suppose if you want to have attack, we can have an AI solution, for example, an AI model, machine learning model, trained with basic information, which we call features of the feature values, data sets. And if the attack changes its behavior about how it's being launched, there's not going to be any problem because the behavior, the results of the attack through the network behavior is going to be the same. Okay. If the behavior change again, we're going to be actually improving the information, improving the data sets. We're not going to changing the solution itself. Okay. So we're going to be evolving with the attack itself. So that's why we're going to be needing AI solutions at the first place. But of course, the AI nowadays, since I do believe that we are on the area of AI revolution, we're gonna be needing a
Reza, your
brief
audio is not working well.
overview of what do we actually need from these AI solutions. Of course, is it good right now? How is it right now?
It's
Is it
usually
clear
Yes.
right now?
it's usually
Yes.
quite good. Occasionally, I think it might be a network lag or something that
Yeah.
affects the audio.
Okay, sorry. I'll just try to continue. I was telling that since we're talking about the AI solutions, I'm going to have a brief overview of the AI's uh, definition that we have right now nowadays. Okay, uh, since we're on the area of AI revolution, most of the AIs that are actually being used uh, what I'm trying to say is that the definition of AI is actually changing to large language models. Okay, as you already know, for example, ChatGPT, Gemini, things like this. But we got to actually figure out what is our needs. Okay, so since we're talking about the network security, specifically detection of an attack, are these large language models are going to be really useful to us or not? I'm not denying the power of these type of AI solutions, but I'm going to say that we can even work with a simple machine learning solution, for example, and it's going to be really accurate. And that's not necessarily need to actually be dependent on the large language models, okay? AI itself, the definition is that, of course, it's not going to be the most accurate definition since I'm not an AI technician, but it's actually trying to teach the computer to mimic the behavior of humans' brain functionality. Okay, it's actually teaching it to think like human, but right now, nowadays, it's actually just predicting some values, which is the functionalities of the machine learning. So when we talk about the large language models, okay, you can, as you can see it in the slide, you can think of the large language model as a car, an automobile, automobile car. And the engine of the car, it's only machine learning. It's called large language models. And the model section is actually, the model is an algorithms fine-tuned with some kind of some specific parameters, and then being trained either previously or and then continuously through some learning process. And the most important feature of the AI is the learning, okay? And that's the place that categorizes the AI type of algorithms and models and things like this. But thing is, what I'm trying to say is that these large language models are really going to be costful. They're going to cost a lot, both resource and in case of financial things. And of course, they're gonna need lots of power. And what will they will give us at the end is that since it's large language models, the language model section is it's because they are actually learning to predict our language, humans' language, and then give the answer based on what they're learning and trying to be some kind of assistant to human. But in network security, let me just change it into here. Sorry. But in network security, for example, when we want to actually detect an attack, this is not necessarily what we need. We actually need that core functionalities. Okay, we do need to actually find that is an attack taking place based on current information of the network or not. Okay, it's going to be like a binary thing. For example, a binary it's a yes or no question. It's not going to be yes. It's going to be taking a lot of attacks happening. This is the we don't need the analyzation. Okay, the analyze is for human. What I'm trying to say, and for detection, we need the system level thing type of things, and that's why I brought the idea of actually comparing the machine learning, for example, as a much simpler solution in compared to the large language models. The large language models are going to be cost a lot, and it's not going to be practically used by everyone. Of course, we can use their APIs, for example, ChatGPT's API to actually use as our solution, but that's going to cost again. And again, in security manners, we're going to giving out some information. Those information might even be used for actually further improving the models itself. What in case of a machine learning, for example, I'm just making an example of the machine learning. We can use unsupervised techniques as well and things like this. It's just a concept, the overall concept. In case of a machine learning, it's not going to cost that much. It's not going to be needing that kind of intense resource power. That's not going to be actually giving out some kind of information. Matter of fact, you just the only problem here with the machine learning is that gathering information and creating your own data sets. But in fact, it's going to be more customizable and more personal to your own work. So here's the whole idea. For example, suppose that we're going to be using a machine learning here. We're going to train it based on the overall data set and the information that we have gathered, specifically through the P4 data plane processing. And we're going to be training the model either live with the information that P4 is giving us, P4 switches are giving us, or prior with the data set that we previously have. And then we're going to be actually predicting based on those information, whether the type of attack or it's the benign user or not. And the overall schema will be looking like something like this. So we're going to be actually depending on the control on the P4's programmability functionalities to actually extract those information that we need in case of security fields, for example, detecting attacks again. We're going to be needing two sections, the network information extractor, which is the P4, and the prediction module, which is the AI solution. And these two will actually greatly make a good team in case of detecting and mitigating those type of attacks. So with all this in mind, we're going to be having the final section of our talk. Of course, as we already mentioned, the P4 devices, P4 switch, is going to be the network feature extractor in case of the AI solutions. I'm going to be referring to AI solutions as the machine learning model, for example, right now. For that, we're going to be needing network feature values, okay, in order to have a prediction. And P4 is going to be providing us those information. And the overall idea, you see, I've come across different solutions nowadays through reading the articles and papers and things like this. And we have mostly three sections in case of a P4 plus AI solutions in security concerns. One section is the controller, of course, the undeniable section of the SDN itself. And we do have the P4, which is playing the network information extractor role in any kind of scenarios, and the AI modules. And the reason that I brought this connections that is like this is because we have almost two kind of scenarios in most of the works. Okay, the first scenario will be looking like something like this. Okay, mostly the P4 again, it will be extracting the feature values for us, and we have two type of things. Okay, either we're going to be using a dedicated device which is empowered by powerful AI solutions itself, for example, smart mix that are having some kind of evolves nowadays. Or the other one can be actually the AI, for example, machine learning techniques implemented inside the P4 switch. Of course, the smart NICs are really great technologies. Of course, I'm a fan of them, but the vendor-specific devices, again, in Rio, which we implemented the AI solutions, the machine learning, for example, models inside the P4 switch through the programming. This is not going to be actually practical now. They were trying to propose a few simple machine learning models, tree-based, which actually trying to bypass those limitations that we have in the P4 programming. For example, lack of loops, lack of division, things like this. They're not going to be actually practical. Of course, no disrespections. They were trying to actually show the potential of the P4 switches, and their works are actually valuable. But if we had some kind of improvements in the P4 program, P4 language itself, then we could have some kind of game-changing, I have these ideas, some kind of game-changing P4 AI solutions in case of network security mechanisms, okay? So this is one scenario. The other scenario is actually that through the scenarios that have been proposed is actually having the P4 switch to extract those information and then providing those information toward the external module, which is the AI module. For example, because it's consisted of machine learning, supervised, unsupervised, reinforcement learning, deep learning, things like this. And the actual point of this is that they will be providing us with the feedback toward the controller, and then the controller here is actually deciding what's going to happen. The thing is, the controller is not going to be doing any kind of tasks. It's going to be more customizable in compared to the previous solutions. Of course, here in both scenarios, both SmartNICs and hardcode, we have some kind of limitations. The customizations is not that kind of available in compared to this kind of scenario. But yeah, this is another scenario. I have proposed my solution mostly based on this scenario because I can have my AI solutions here the way I want, and I can actually define the extraction of the feature. I was able to actually extract 33 network-related machine learning features from this P4 switch live periodically, and they were trying to feed the controller with these information. Maybe you can actually implement some kind of application to further analyze the information. The whole idea is that we have more customizable here, and I personally prefer these kind of things. And the thing that I implemented was for a detection of that slow rate DDoS attack was looking like something like this. Okay, we had this P4. It was extracting those 33 features and live, and it will periodically or just in case the controller detects some kind of for example suspicion to attack kind of situation, it will get those information, and the information will be fed to the external detection module, which is consisted of for example random forest, KAN, MLP, and decision trees, and they will provide me with the feedback. And I have added this externally to prevent actually enforcing controller to having more processing. Okay, we can add this, the resource of the controller, since AI solutions are actually resource in needing some kind of resource. And the final results, of course, if you're interested, you can see the P4 HTTP guard article of mine. It was in the cluster computing of the Springer results from my another previous works. And you can see here, for example, the difference between the type of I've implemented two scenarios, one with the OpenFlow switches and the other one with the P4 BMV2 switches. And you can see the difference. Okay, this is the bandwidth consumption of the attacks. Okay, you see how much of bandwidth the attacks has here, and how much it was in case of the P4 scenario to actually detect those type of attack. Okay, and this is DDoS. It's not DOS. It was distributed through the different hosts. You can see if it has been detected and mitigated much faster. And this is the actual results that you can see for the controller itself. The controller, of course, was more actually engaged in case of the general purpose devices, which didn't have that kind of functionality to extract the information that we this is basically everything I wanted to talk about. It's just, of course, the talks about P4 and AI, specifically AI, needs hours and hours and talk, and it's endless talk. Uh, if I was gonna talk about the most useful feature that I found in the P4 language, and I mentioned it somewhere in the presentation. And for me, it was the stateful data processing. Okay, if we can even improve with this functionality, that would be very great. Without the stateful data processing, of course, none of these feature extraction, none of these actually storing and restoring and recreation and modification would have any kind of meaning, of course. That would be just actually modifying the packet processing procedure. Okay, from my opinion, it's the stateful data processing and hash functionalities specifically are the greatest functionalities of the P4 language. Of course, the overall control that the programmability has bring to me, it was really, really useful. It's like, for me, it's like personally using, for example, Linux operating system against other type of systems. Okay? You get the idea. We have that kind of freedom that we can implement anything that we actually have in mind. And that's great. But alongside with those advantages, I've actually come across some of the limitations. Of course, I think you are in guessed it through my talks. It was I've mentioned this one time in the P4's. I think it was the GitHub's repository, and Andy himself mentioned that there's no specific or direct timing methods. For example, for me, when I was trying to actually get some kind of timing information, I was trying to do some kind of tricks and get my information through the packets. It would be great to have some kind of thing. Maybe there's something implemented and I'm not maybe updated, but I would be if there's anything implemented. The other one is that division operations, of course, if game changing. I don't know. I didn't really get the reason that there's no division operation. I read it, some kind of reasons for that. It's not needed. Of course, we do have some kind of shiftings, but for most cases, having uh, complex mathematical equations, we need that kind of division. Of course, that's going to be great if we had that kind of ability. Of course, I'm talking about the BMV2 simple switch. I've heard that the Startum switches have become open sources, and that's going to be really useful. But specifically about the BMV2, that was the problems that I faced. They didn't stop me from doing the things that I want, but I have to actually come across the ways that I want through some kind of tricks. And for example, having it would be great to have the access to the, for example, some kind of meters and things through the P4 code itself. That would be some kind of great things. And another feature that I thought that maybe that would be useful is that actually accessing the payload values. Okay, we can access the payload values through the packet headers, but you see, when we trying to actually process the HTTPS, for example, values in the payload, they are encrypted. I was trying to think that maybe it would be great to have some kind of functionalities inside the P4 to, for me, as for example, a network administrator that has some kind of fixed key as a demonstration, that for me, I would be able to actually compare the values and decrypt and actually get direct access to the payload values. See, you get the idea. For example, suppose we're actually analyzing the packet's payload through the Wireshark or T-Shark, something like that. We see the specific payload value. That would be really great. And yeah, that was the things that I faced as some kind of limitations, not problems, limitations, and the possible improvements that I did. Maybe that would be great to have. Maybe adding some kind of APIs for external applications to our BMV2, since BMV2 is simple software based, and I really like to work with them. Maybe providing some APIs to actually being able to work with some, for example, external AI modules. That would be really great idea. Maybe Yeah, this is. And I wanted to really thank these three guys. Of course, the first one is my supervisor, Dr. Reza Mohammadi, who actually introduced me to P4. It was the beginning of my P4 journey. And of course, Andy himself, which has dedicated lots of time and efforts to the repositories, updating things and answering the questions. Of course, the same thing for Anthony Best. Of course, when I was trying to implement my first projects, I remember that I directly sent an email to these to Andy and Anthony, and they actually warmly answered me, and that was really great help. And I owed them this appreciation. I just wanted to say thank you, guys. And of course, for Dennis Barton, thank you for your actually coordination behind the scene and your support and giving this opportunity to share ideas here today. And that's pretty much everything. Thank you, guys, and trust in P4.
All right. So if anybody has any questions, please enter them into the chat. And while waiting for some of those to come in, I have a couple of my own. I'm guessing, so you mentioned some research papers. I didn't notice any links in your talk, but I presume you've got some web page for your personal research
Uh-huh.
and publications,
I
probably.
thought maybe I'm not allowed to. I thought maybe I'm not allowed to bring those research papers for I don't know. But I do
Oh,
have it. Yes. I can bring it here if it's.
I, I think it's fine if you maybe send it to Denise and I afterwards. No reason to rush and do it in the middle of the talk right now. But I think for some people that
Sure,
might,
sure,
I think there might be some people interested in following up on more details of some of these things, and that would be a great
sure,
way to do
sure.
it, I think.
Uh,
Um,
Sure thing.
what,
I mentioned it's called the P4 HTTP guard, and I will send the link for Dennis, of
okay.
course, for possible sharing it.
Great. Let's see. I do see one question that's come in. Let me read it here. Thanking you for the presentation. And they ask if I'm not wrong, you have implemented your solution in the BMV2 architecture. Have you tried this on any production level switch like Defino? That's the first question. There's a couple follow-ups. I'll let you answer that one first. Have you used
Uh,
any either Defino or SmartNICs or other hardware targets? Have you attempted to implement? Is it true that you've done your
Sorry,
implementation?
one more time. I didn't quite catch the question.
Is it true that you've done
Yes,
your
yes,
implementation so far in BMV2?
yes, yes, of course, I can even show you. I've actually the whole thing that I explained you was based on the previous work of mine. I've that was the first one. I have two more works coming up, and of course, for the new year, I have some more ideas to continuously was. Mostly I worked with the BMV2, not the other type of. I've not worked with the Tofino ones, but the BMV2 is the one that I have worked with. Yes.
Okay. Let's see. Another question. Is your P4 HTTP guard implementation available in GitHub?
No, unfortunately, it's not available in the GitHub. It's in the cluster computing of Springer. I can just show you real quick here if you give me the time.
Okay.
And it's
Again, that's
available
something
in
that I
the
think
glue.
find a follow-up after the talk too, if it's takes a couple minutes to find.
No, no, it's just here. You can search it
And
in Scholar.
okay. And if there's one more question here. Let me read it. I saw some papers who converted DT rules to P4 program to apply machine learning rules. Do you consider are you familiar with this, and do you consider it a good idea or advisable?
I didn't quite catch the question. Do you mean by converting it to EMV2? I didn't quite
Okay.
catch the question.
So they was asking, let me just try reading it one more time and see if it I
Yeah.
saw some papers. They converted DT rules. I don't know what DT is. Maybe are you familiar with that?
Decision trees, maybe?
Probably, yes. They converted decision tree rules to P4 program to apply machine learning rules.
Yes, it's a great question. I've mentioned it briefly in our talk. You see, the decision trees are actually first things first. There are different kind of decision trees. Okay, there are the ones that has some kind of loops, and they don't. There are types that doesn't have that kind of loops. Since we don't have the loops inside the P4 code, so they were dependent on those type of decision tree types. And the other thing is that how big of a decision tree are we talking about? Okay, when we're talking about implementing decision trees inside the P4 code, we're talking about hard coding everything. Okay, we have to consider the features of these decision trees. We have to consider fine tuning these features, the informations. Okay, we're talking about the decision trees. We're gonna be teaching them based on some information. How big is the information? How big is going to the decision tree to be, and is it going to be
Sorry, see there.
for example, dynamic, or is it going to be fixed? For me, most of the things that I've come across, they are great for demonstration. They are great for able to do things. But I personally think that these are considered some kind of static solutions. Okay, we cannot practically depend on the type of implementing the decision trees inside the P4 switch because it's basically hard coding everything.
Okay. One question I had, you mentioned something around 30 some features that you extracted and used to feed into your machine
Yes.
learning. I've seen some work on machine learning where they actually do kind of a sensitivity analysis. They one at a time, or sometimes in groups, they'll remove some of the features and then rerun their machine learning and see if they can get as good of results, or what, basically
Yes.
if you can completely remove a feature and your results are just as good, probably that feature wasn't
Yeah.
helping you. Whereas if you remove it and the results get suddenly worse, then that feature seems to be more critical. Did you
Yes.
do any kind of sensitivity analysis like that, trying to figure out which features were
Uh,
the most useful?
Of course, these section of the you see when we're working with the for example, machine learning solutions, these are the type of sections that we do prior to actually implementing the final idea. Okay, we're trying to actually it's called feature extraction, but not kind of feature value extraction. We actually try to fine tune the values and find the most important features of the networks. It wasn't 33 features, it was like hundreds of features that I try to find out which features are actually most important for me in case of detecting different type of attacks. For example, this is slow loris, this is, for example, slow send, slow post, things like this. uh, uh, the features that I've chosen was not at the P4 stage. Okay, I've chosen those features prior to my work because, for example, in my case, if you remove one of those features, the whole work was going to be collapsed. Okay, they were lacking like different gears working with each other. Okay, if you take some of those, it will either block the benign host, for example, as an attacker, or it will actually misguess the type of attack or things like this. It will result in the accuracy.
So you effectively you had already done that kind of sensitivity analysis
Yeah.
before getting down to that list of 30.
Before actually implementing,
Got it.
and I've implemented the result in the P4 switch. And do I have enough time to actually show the P4 HTTP guard here? Just sharing my screen real quick.
Yeah, if you just want to, if it's just for like a URL or a location web page or something to share with the group, that's if it's quick.
Yeah, this one you can see it's in the cluster computing of the Springer. It's P4 HTTP guard for possible interest community members. It's written by me and my supervisor. This is my first work. Of course, it's been uh, I don't know. I think it
Yep,
was
great.
2022 or things like this. I've
Thanks
got
for the. I imagine P4 HTTP
volunteers
guard is probably
works coming up.
great. Yeah, I think that'll help people find it, and Google
Thank
it for
you.
it and find it. Well, I think that's probably pretty close to our time here. I wanted to thank Reza for
Yes.
Great talk there. That was very interesting, and thanks for the volunteering to come and talk to us. And thanks for all our people that joined and submitted questions today. Uh, have a great day. Thanks.
Thank you. Thank you very much for giving me this opportunity.